of excavations in general. So it's got a bit of a safety focus. We're going to do a little activity near the end on volumes, working out volumes, like how much dirt you might dig out. I was busy all last night editing this to update it from what we had previously, so it goes all right. Right, so what is drain laying work? Well, I can tell you it's not plumbing work and it's not gas fitting work, because they're all two separate trades. So technically, under the PGDB Act, drain laying is classified as these things: laying a drain, altering, reconstructing. So I'm just going to mute everyone. If you're not talking, can you just mute yourself? Yeah, just get a bit of feedback otherwise. Altering, reconstructing, extending, repairing, opening up or renewing a drain, or fitting a connected to a drain. So basically going anywhere near it. Fixing or unfixing a drain to or from a sewage tank, fixing or unfixing a gully trap, or other trap connected with the drain or sewage tank. So a gully trap is probably the bit that you see quite often on a drain, which is usually got a grate. Quite often they're rectangular, sometimes they're round, and your waste pipes go directly into that in a standard setup. Basically, the other way of looking at it is everything outside the building envelope, if it's in the ground, is drain laying. If it's actually under the building, inside the building envelope, even if it's in the ground, it's called a pre-slab, but it's technically sanitary plumbing. If it's above ground, it's also sanitary plumbing. So that's pretty much it. If it's outside the boundary in the street, it also becomes a network thing. So it's slightly different then as well. Right, before you go and do a drain laying job, what do you need to look out for? You need to go and do a site inspection. You need to have the plans of what you're going to do. Obviously, it depends on the job. If you're going to fix a block drain or something, you need a drainage machine. But if you're going to lay a new drain or repair an existing one, you ideally would have a plan of what you're going to do if you're altering it. And then you need to go and check out site conditions, because it can be quite different for different sites. Some might be nice and flat with sandy soil. Other places might be on the side of a cliff, in Wellington somewhere. It's all rocky and clayey, and it's a very difficult site to work on. So you need to get a grasp of that. Plans can give you some of that information, show height changes, things like that, but they're not going to give you the actual site conditions. Right, how about in the chat, or even by unlocking your mic, you give me a few problems you might come across doing some drain laying work. What do you think might be an issue, other than what I've covered? Anybody? Yep. So Tiger's chipped in. So he's got other pipes in the ground. So yeah, there's a whole heap of other services in the ground. Yep. Wires. So hot electrical cables, data cables, fiber, trenches collapsing on you. Yep. So the ground is not always stable. The deeper you go, the more at risk you are. Also, if there's other vehicles and buildings and things close to your trench, it makes it more likely to collapse. Hazards, yep. Trees, roots. So yeah, there's a whole heap of hazards, and we'll be looking into some of those, but there's a whole heap of hazards that you may come across. Some are quite obvious, and others might be hidden. like cables in the ground or other services in the ground, gas pipe in the ground. If you haven't pre-identified where it's likely to be, you could easily run into a lot of bother if you ripped through it with a digger. It could become very dangerous quite quickly. All right. So here's a few things to consider. So you've got to go and do this drain laying job. First thing, check the plans if you've got them. If you're doing a new job, you would have consented plans. So you need to make sure that they are consented. They're not just draft plans, and that they've got all the right information on them. So it's got the right address, it's the right job, so you're not turning up with the plans for next door. And what information do they have on them that you need to know? So they may have a legend, which has got little symbols on it, and that can tell you specific things like where a inspection chamber, a manhole, or a gully, or something like that needs to go in the plans. And we're going to break down these other bits as well. So a big one for safety is checking for other services. So even on someone's private property, there may well be existing services running through it. It's not uncommon to have a sewer main or a stormwater main run through the back of a property. They're not always in the road, so sometimes they're running through people's backyards and stuff like that. And also, depending on where you are, you may come across all sorts of other services. So any house that's got underground power or gas supplies, they're going to be in there somewhere, existing water mains. So you've got to work around all those in a safe way. So the first step is to check the plans and potentially get a location services provider in to locate and mark all those for you. Even visual checks, so just by finding the Toby box gives you an indication of where the water main might be, and or looking where the gas meter is, so you can take more care around those areas. So typically when they are locating the services, they're going to mark the ground, so they're going to mark it with different spray cans for different services and write what's in there, like in this example. So they've got no gas, no telecommunications, it's like no power. So this is the marking guide. So if they're spraying it on the road, they're going to use these color codings to identify it. So electricity is orange, gas is yellow, telecommunications is purple, that's with the spray can, water blue, wastewater red, and stormwater pink. And then they'll put that symbol to identify what it is. So SS sewer, SW stormwater, W for water, T telecom, G gas, E electricity, which makes sense. The actual pipes in the ground, there's no real guarantee exactly what colour they are because it'd be really old and they could just be corroded metal. But the ducts that they're using or likely to install currently, electricity would be an orange, gas is going to be yellow, telecom uses a green conduit, water blue or white, wastewater light grey, stormwater dark grey, although they may all be sort of an off-white like PVC pipe depending on where it is. So talk to the service providers. So find out, obviously not so much you guys as a pre-trader, but as a business, if you're working in drainage, this is the type of thing that's going to happen. So communication is pretty key. So you check your plans, you talk to the right people, the people that own the networks and or the specialist companies like Before You Dig or Utility Location Services. There are a couple of examples of specific location service companies, so they actually go out their job. All they do is find services with underground radar or various stuff, equipment like that. But the service providers, like the gas network people or the power network people, will know where their network is, so they may find it themselves. In some cases, if you're close to it, like a high voltage cable or something, you may have to get a permit to work in that vicinity. And in some other cases, they may even have their person on site standing over watching what you're doing to make sure you don't damage their network. So it can get pretty technical. That's more likely to be stuff in the road, like what these guys are doing, water main repairs or stormwater or sewer repairs or replacements. So this is sort of what I got into. So a permit or standover. So in some cases, higher risk cases, not normally a domestic house or something like that, but in high risk stuff on the road, that you have a permit for you to do certain work. So also part of that is planning the job out carefully, how you're going to do it, how you're going to avoid damaging the services. So usually you would identify the services first. So someone would mark on the ground where the services are. You would use your machine, and then within like a meter of the service, you'd stop using the machine and hand dig around those services in a safer way. In some cases, they'll actually use a hydro truck. So it's basically a water blasting truck with a vacuum on it, and it blasts all the dirt and gravel out, and then it sucks all that out to expose the services without you actually having to get in there so much. That's sort of big scale stuff, roading type stuff, but it's all part of drain laying. Also have a plan in place, so if something does go wrong, everyone knows what they're going to do. Do you think they dug through here with a mechanical digger? Give me a comment or unmute. No. Yeah, no, it's a couple of no's. Yeah, because even the best digger driver in the world, one, you can't always see where your bucket is. That's one issue, because you're back from the hole, and as the deeper you get, you don't always have the right angle to see where your bucket is. There's a whole heap of pipes in there. So you got green telecom, you got a blue water pipe. It's like a yellow gas pipe. Don't know what these other two are. Could be anything. You've got to presume they're live. They could be dead pipes, but they might be live as well. Could be power. So yeah, they would have had to definitely hand dig that out for safety. And that should have identified where those surfaces are beforehand. Because a digger bucket, the bigger the digger is, you just think you're pulling a tree root or you've hit a rock or whatever. You don't really have that feel to know that you're actually ripping a power cable or something out of the ground. It'll just rip through it. So that's why you need a spotter and or pre-identifying the services, and then your spotter is also the hand digger who's going to carefully dig around those services. And you actually want to dig down the face of a trench, breaking it away rather than dig from the top down, because otherwise you can put the shovel through the service as well. I'm going to try playing a little video clip. So this is water main repair in Christchurch, just to break it up. See how it goes. So you can see the existing joint between two pipes is failed, pissing out a lot of water. You can see all the corrosion problems that have caused it to fail. Half a bolt left. And the surface of the pipe is also failed. It's no longer smooth, so the rubber gibbolt can't seal effectively to it anymore, which is why it was leaking so badly. So it's like a compression joint. So there's the repair. They've just cut that section out, put a new bit in and two new gibbolt couplings to go between the different materials. So they've got a big thick rubber ring on them, and when you tighten them up, they compress the ring onto the pipe. But when they turned it back on with water, it actually slid off out of position, so that wasn't too flash. So they had another go. So this time they chopped them apart with some timber and used some galv strapping to hold it. Although seeing the original galv bolts corroded away to nothing, I don't know how long that will last, but I guess it's better than nothing. The gravel might help hold the chocks in position anyway. Probably a big bolt that went right through both bolts with a back nut would have been better, but I didn't think of that. Might have been hard to line them up. Working hard because it's in the night time now, so it was an all-day job. So they were using a little sump pump there to drain down the excavation as it was filling up with water, just to pump it out so they could get in there and do the work. Obviously, they would have had to shut off that big water main to actually cut that section and repair it as well. So quite a few people would have been out of water for quite a while they did that repair. So it would have been pretty urgent to get it back up and running as soon as possible. Right. Planning excavations. So when we're going to dig in the ground, there's a few things that can go wrong, or factors that can contribute to the trench failing. So the deeper it is, the more hazardous it is, but even shallow trenches can collapse. There's less chance of you being injured, but quite often you've got to bend down to the ground level to fit the pipe or join it. So that does leave you quite exposed if even a moderately deep trench like a metre deep collapses. You could still potentially get injured or stuck under there. So factors that feed into the risk level is the depth of the trench, the type of soil, or if the soils are layered. So if it's just not one type of soil, quite often soils are formed in layers, so they're likely to separate where you've got two different layers of soil. Vibration, so any vibration from compactors or vehicles close by could cause it to fail. Presence of moisture, rain, or a high water table. In some cases, the water level will actually be above the bottom of your trench, and you have to actually pump that water out to lay the drain. Even in that one where it was leaking, they had to pump the water out that was coming from that water main so they could get in there and work around it. That can affect the ground stability. Any superimposed load close to the edge, so if you're using a digger or an excavator, you've got trucks or utes or things close by, buildings, they're all putting a load on the ground, and that can put pressure on it and cause it to collapse. It's a ballpark a 45-degree line from the base of the trench plus a metre is a safe distance back, so it's quite a long way, further than you'd think. Also, the time the excavation is open and if the soil's been dug up before. So if it's all virgin ground, it should be reasonably stable, but if someone did a repair in a similar area a week ago, that ground's not going to be as compacted, it's much more likely to collapse. Another little video clip for you here showing what a trench collapse might look like.
Example, if a 6-foot long, 4-foot wide section of an 8-foot deep trench collapses, about 10 tons of soil can fall on a person.
Can see it once more.
If a 6-foot long, 4-foot wide section of an 8-foot deep trench collapses, about 10 tons of soil can fall on a person.
So 10 tons, you know, that's it's very, very heavy. So there's no way you're going to be able to breathe even with 1 ton, 500 kilos on your chest. You ain't going to be breathing, even if your head was out of the ground. So it is quite dangerous. So here's a true story. About the photos aren't necessarily related to the story, but unfortunately people have died in the drain laying industry in New Zealand, and more than one. And here's one situation there due to trench collapse. Man's dead after a trench collapsed on him at a site in Nelson on Tuesday morning. Police this afternoon recovered his body, named the man as Shane Darwin Cockcroft, 34, a worker for Burgess Crowley Civil Limited, site which was cordoned off by emergency services. Mr. Cockcroft died when an estimated 1.5 tons of wet clay fell on him, burying him to his chest just after 8 a.m. today. So it's first thing in the morning. Ambulance staff said it appeared he'd suffocated immediately from the pressure on his chest. So 1.5 tons, there's no way anyone can actually deal with that weight on top of them, and it's just going to knock all the air out of your chest straight away. And then no one can dig you out quick enough. You've only got a couple of minutes to rescue someone, and that's just impossible. Even if you got the head free, which you probably wouldn't do in a short time, if their chest is compressed, they can't breathe anyway. So that's why it's important that we actually work in a safe way and plan the work so we're reducing the risks down to a safer level. So clay is normally quite stable, but this clay was saturated, it collapsed. Maybe they thought that it wasn't a risk, but it obviously was, and they should have had some protection in place. Other issues that you can find doing drainage work is actually ground gases. So it's an even less obvious one than the trench collapsing on you. But there's actually a range of gases produced naturally from decomposing soils and things like that in certain areas where they may be an issue. They may be flammable, like these gases. Hydrogen sulfide is also poisonous. And even a non-poisonous gas, if it's displaced the oxygen, because it's denser than air, then that can cause you to suffocate as well. Carbon dioxide, hydrogen sulfide. So there's sort of three gases there. Methane, which is also known as natural gas, but it can form naturally from decomposing organic matter. Hydrogen sulfide, which can be in the ground normally, also in sewer gases and stuff like that. And then carbon dioxide also from things breaking down. Another one is also carbon monoxide from vehicle exhausts and generators that can potentially build up in an area, and it's very poisonous. So the hazards aren't always obvious, especially if you've got little experience. So you're quite reliant on more experienced colleagues to keep you safe initially until you build up some experience. So some things you might think are reasonably straightforward, like overhead power lines. But if you're a digger thinking about what the hazards are in the ground, you're not necessarily looking up at the power line or thinking about that. But if your boom can reach up there, it could see the steel and the thing could liven it all up, and could fry you in the cab. So that is a big risk.
Wouldn't a lot of diggers take that into account and have measures so that it goes back into the ground?
Like an earth?
Yeah.
Well, they will be touching the earth, but it doesn't mean that if you're on the path of the current, then you might still get fried. So you don't really know. It would definitely be something you'd want to ideally work away from that area, or possibly, they can get them sheathed. So they put like an insulating section across it, like when people are painting their houses, because it's like if the power line falls down on your car, you drive into a power pole or something, you can get fried in your car because you've got live wires potentially touching the metal of your car, livens it up, you're in there, you get zapped as well. So the other thing is the swing radius of the boom and the back of the digger. So it's important that you're visible, and you actually, I'd really stay out of the way of the swing rotation of that digger. So if you need to talk to the digger guy, one, you should have high vis on, hard hat if you're working around mechanical equipment like that. And you might be his spotter, so you want to stay line of sight with him so he can see you from his cab, but you're actually staying just beyond, like a meter beyond his boom reach, so he can't knock you out, because you get a half a ton digger boom or something whack into you. Well, he doesn't feel it, but it just it can kill you, could certainly seriously injure you. So you got to work together. If you want him to stop, you have a hand signal. So put your hand up, stop, whatever it is. He puts his boom down, turns the thing off, or turns the thing right down so he can't bump it and turn it on, and then you walk up and talk to him, or he jumps out and talks to you. So you've got a communication plan in place beforehand. Also, you don't want other random people sneaking up behind him, because he might swing around to put some dirt in the thing or whatever. He might back up, run someone over, they're dead. It's Could be a 20-ton digger. Might just be a little 2-tonner, but even that could do quite a lot of damage to someone. Similar thing with vehicles. Now, this picture here actually shows what I was semi-alluding to earlier, is that the imposed load is actually what they call the zone of influence, and it's actually 45 degrees in good ground conditions back from the base of the trench. Plus, you need to keep a metre back from that. So if you're piling up soil you've excavated or something, it actually needs to be the depth of the trench away from the trench plus a metre. So if you're 2 meters deep, you know, you're 3 meters away is where you're putting all your soil. It's quite a long way away, further than you'd think. But if you pile it up close to the trench, what that means is there's a whole heap of extra load, which is likely to cause it to collapse. So WorkSafe. So WorkSafe are the big government safety organisation. They've got a document which is a code of practice for excavation safety. It's quite a good book. I'll put the link on your Moodle site. A lot of this info has come from here. So that's kind of the how-to guideline for doing excavation work, how to keep safe. So drain layers need to be aware of that. We certainly look at that in the level 4 apprenticeship. They're actually provided with a copy of that at level 4. And they have a lot of questions relating back to it. So a few general things: identify the hazards, locate the services, fencing, warning signs, stuff like that, because you've got to protect yourself and the public from falling into your hole. That's a legal requirement. Having safe work systems, which is part of that communication. Who can do what, where, when, how you do things, how you lift things, how you move things. Protecting your excavation. So in this case, they've got some hydraulic shoring this guy's standing within. So that's protecting him from trench collapse because he's pretty deep down there doing that work. PPE, high vis, steel cap boots, hard hat would be your bare minimum. And then emergency planning. So if something goes wrong, as part of your identifying hazards, what are the potential things that could go wrong, and how would you deal with it if it did? So you're trying to eliminate or minimize them, but there's still some potential for risk there. So just building on one of those in a bit more detail, what it might look like on a job. So for fencing, a couple of examples. You get some warning signs leading up to the site, then around the site they're fully fenced it to keep public out and or other workers falling in by accident. So any work where the public are exposed to it, it's like sort of roadworks type drainage, you're required to make sure that you're not creating a danger to people, so that you've actually prevented them harming themselves. Now, what that might look like is a fence at least 1 metre high with a combination of signs, barriers, lights, markers, flags, even sentries to keep the public safe from themselves. Excavations likely to collect or retain water that might form a hazard to children or people must be covered or fenced off when you're not there. So usually they just use big sheet bits of steel and put those over the hole, and or even drive their digger up, put the digger on the steel, the boom, the bucket on the steel to stop it moving anywhere, and then put a fence around that. So, maybe with some lights on it if it's on the road so no one crashes into it, plus the extra signs and cones and what have you. So it can get pretty full on. But that's a requirement, so you don't get prosecuted if some drongo falls in the hole and injures themselves. So if you've done all that, you've got your signs, your fence and whatever. If someone climbs over the fence and breaks their leg climbing over the fence, well, that's on them because you've done everything reasonable to prevent them getting injured. But if you did nothing, if you just dug a big hole in the middle of the road and parked your digger on the footpath, and someone rode along on their bike and fell in there, then you'd be prosecuted for, the company would be prosecuted for not protecting the public. So the most common protection shoring for deeper trenches in New Zealand would be a trench shield, which is this one here, which is basically just a big steel box with strong bracing and some lift hooks that's lifted in and often dragged along by a big digger. So that's kind of over-engineered that if a trench did collapse, it would be strong enough to take that load and protect you, provided you're still working inside it. Another variation on that, which is a bit different, is shoring, and you're going to at some point do some timber shoring, which is sort of the most basic version. We've also got a hydraulic shoring system, a quite small one. You could probably have a go at that as well, which is more like this one shown in the picture to the left. The advantage of shoring is it actually supports the trench face as well. So it's more suited if you're on a roadway and the car still had to drive past, it would actually support that trench face. A lot of these ones can actually be dug in by a digger, and it digs inside it and then it pushes it down as it goes. And it can also pull it out again. So you don't actually have to be in there building it or anything. You get in there after it's installed. With the timber shoring, unfortunately, you've got to dig the hole and then you've got to build it. So you're actually at a level of risk while you're constructing it, which is not as ideal. But these ones, you don't get in there until it's protecting you. And full shoring like this, if it's over-engineered, could also potentially allow other vehicles closer than that 45-degree zone of influence. Whereas this one, the trench shield, is just a protection for you. So it doesn't actually support the trench face. It may sit inside the trench face. It just means if the trench does collapse, you're still safe. So there's a slight difference between the two. Another less common way of keeping you safe in a deeper excavation is just to dig out a whole lot more dirt. So you basically remove all that extra soil or ground to a point where if it collapsed, it wouldn't be a risk to you. So there's two ways of doing that. There's benching, where you cut it into steps, approximately 1 meter high. So if it did collapse, you're only getting sort of a meter's worth coming towards you. Or just taking it right back to a 45-degree slope, which they call battering, which basically you're at such an angle that it can't collapse anymore. It's already sort of at its stable level. Downside of those is that you've gone from having a relatively narrow trench in excavation to a massive big pit almost. So that's why it's not usually used. There's a lot more work to dig all that out, and then a lot more work to put it back in and bring it back to how it was beforehand. Obviously, these ones wouldn't be too suitable in the middle of a road. You'd be digging up the whole road just to lay your pipe, which is why they use trench shields or shoring. So another factor that can cause trench collapse is water flowing into a trench or a high water table, which might mean you can't even do the job in the first place. So in some cases, like they're doing some stormwater main replacements in Jackson Street and around there going out to the beach, because the water table is so high when the tide's in, it's only like maybe 1 meter deep, the water level underground. So when you dig deeper than 1 meter, it fills up with water pretty much straight away, which makes it very hard to do your job. So what they had to do is do what's called well pointing. So they have all these shafts stuck in the ground around the area that you're going to work, which are basically filtered tubes. they're all hooked up to a big manifold that's hooked up to a big surface pump. Usually it just looks like a big box. And that runs flat out, and it's a pump that's designed to run all the time, or basically run dry as well. And it sucks the water out just non-stop, and then you just pump it out to an area away from where you are, like another stormwater sump in the road or something, that's not going to come back in. So it just has to run all the time so you can do your job, to stop it floating your pipe, and also you can get in the trench without being saturated with water. Right, well, that was a bit of general info about excavations. Now we're going to have a go at doing this activity. It's a little bit tricky, takes a little bit of thinking, so we're going to break it down into sections. So we'll start with the easiest one, or easiest couple. So we're going to start with C. So all I want you to do initially is work out the volume for C. So volume is going to be, I'm going to write it in the chat, length times width times height. I would suggest, well, it's all in meters, so we'll just work in meters. So using the formula length times width times height, you're going to work out the volume in cubic meters. So let's do that for C, and type your answer in the chat. Then we'll move on to B, and then the tricky one, A, where you've got to think about it slightly differently. Geez, you're quicker than me. Now we've got one answer. Let's see a few to make sure that he hasn't got it wrong. I'm going to have to work it out at the same time. Oops. Yep. So our answers in meters cubed. Yep. So we've got a few answers come through if you're looking at the chat. So we've worked out that C, the volume of C. Yeah, I'm going to type in the working as well, just for clarity. I might put the 0 up, 0.6. There you go. So C equaled 0.36 cubic meters of excavated material, which was worked out by going 0.6 times 0.6 times 1. So that wasn't too difficult. All right, let's move on to B. Same thing, same process. I could probably do that one in my head. 1 times 1 times 2. 1 and 1 is 1. 1 times 2 is 2. All right, got my maths experts chiming in. They're supporting my answer. So we got B equals 2. Right, now we've got the next one. Now the secret to doing this one is you've actually got to split it in 2 parts. I'm giving away all my secrets here, but you've got to split it in half. So you work out one bit, which is 3 meters by 8 by 0.5, and then you work out the other bit, which is 3 meters by 8 by the difference between 1.1 and 0.5, whatever that is. And then you halve the answer to that second part. Seems a little bit confusing, but have a go. I'm sure my top math scholars here can maybe work that out. And if you're not sure, see if you can get at least half of it, and I'll write up the full working in the chat. So have a go at A. I've got a different answer. I'll double check my own answer now. So, we're struggling with this one. Let's, I'll give you a clue. We'll make it easier. So the first part of it, you go 0.5 times 3 times 8. Work that out. Write that in the chat. And then we'll do the second half. Yep. All right, so we've got the first part of the exercise. So the first bit equals 12 cubed, which is 0.5 times 3 times 8. Now, what you've got left is sort of a sloping section, if you like. So the sloping section, if you go 1.1, take 0.5, you get 0.6. So 0.6 is what's left after we've worked out the volume of the 0.5 bit. So if we draw an imaginary line from 0.5 all the way around, we would have 0.6. So the figure you've got to use is 0.6 times 3 times 8. And then because it's actually sloping back to nothing, you've got to halve the answer. So have a go at that. See what you can get there. Getting all sorts of answers coming out now. Got one correct final answer. You know, we've got a few people coming up with the correct total. So the second part was 14.2, and then you divide that by 2. So the second part equaled 7.2 cube, and then you went your original 12 meters cubed. Oops, plus 7.2 meters cubed equals grand total of 19.2 meters cubed. There you go. Wasn't that hard? It's just knowing what to do, knowing how to manage that odd shape. So you've got to break it back down into basically rectangular shapes, and then one, because it goes back to nothing, it ends up being half what it would be if it was the full shape. Yeah, so I definitely had at least 3 people get the correct answer. Now, that was just the answer to A. So we've got a couple more things to do in this activity. So if we take all our answers, which at this point we've got 0.36, 2 meters, and 19.2. If we take all those, add all those up, and then we need to add 20% extra to our combined answer. So add all those 3 volumes up that we got as our final answers, and then see if you can add 20% to that. I'm going to do that now, see what we come up with. Yeah, we're doing well. A few correct answers coming there. Oh, well, you guys are good at volumes. What are you on about? Yeah, I'm going to type in the working. In case you were not 100% on it. Oops, what happened there? All these pop-ups, it's hard to write. Oops, plus. All right. I've done well here. Yeah, every answer that's come through is correct. So that's good. 21.46 times 1.2 equals. Oh, that took me a little while. There we go. So that's how I got to my answer. So I added those original volumes together. 0.36 plus 2 plus 19.2 gave me 21.56, and then times that by 1.2, which is what you started with, plus 20%. And that gave me 25.872 cubic meters of excavated soil, including the bulking. All right. Right. No, so the big takeaway really is, other than the volume, is that it is important that you don't take shortcuts and that you do follow a safe practice. Obviously, initially, you're going to be lacking a little bit of knowledge. So you're reliant a bit on other people. But if you do feel unsafe, raise the issue with them and have a discussion, because it's not worth the risk. If you are really uncomfortable, you probably shouldn't be doing it. Would be my suggestion. Oh, what happened to that last slide? What I did there? Anyway, I'm just going to finish with a fun video. Exploding drones, for the sake of it. It's like exploding drones.
Well, we were have pretty much evacuating the building. We were waiting for the children to finish evacuating.
Don't know where that kid went.